I would like to talk today about 3D imaging solutions for the forensic sciences, and in particular about the Edge 3D microscope from HNU Edge LLC. So why does one need a 3D microscope? The reason is to acquire the hidden depth information that exists within the samples. This allows you to collect more accurate data. This will decrease misdiagnosis and increase productivity. The reason forensic scientists need 3D is because real-world evidence is naturally 3D. Things like bullet analysis, tool markings, trace evidence, document analysis, fabric identification, counterfeits and forgeries, biological specimens, these are all naturally three-dimensional objects. The advantage here is to be able to examine specimens in 3D without destroying the evidence by cutting sections. Let's start by looking at the shell casing of a bullet using the Edge 3D microscope. This is a conventional 2D picture of the end of the bullet casing, and as you can see, there is only a small portion of the image is in focus. Compare that with the full focus image that is created by the Edge 3D microscope. A color-coded depth image allows one to quantify the exact shape that this firing pin produced in the end of this bullet shell. It shows that there's a depth of 750 microns from the top to the bottom. The bottom of the pit is at 0 at blue, and the highest point is red. The depth information can be easily visualized by turning the image into a 3D model. These 3D models can be viewed at any chosen angle. The information can also be visualized by making 3D video loops. Here is a closer two-dimensional view of the firing pin markings. You can see that only a small portion of the markings are seen in focus. Now with the Edge 3D microscope, you can see a full focus reconstruction of the markings throughout the entire depth of the specimen. Now with the addition of the color information, the unique signature of this firing pin can be quantified. Here is a three-dimensional rotational video of the impression made at the end of a bullet case using a different gun. Each firing pin of each gun produces a characteristic shape. And here is the color depth map that corresponds to that particular firing pin. Here are the depth maps produced by the firing pins of 4 different guns. You can see that each firing pin produces a unique depth map signature. Here is a 2D image of a tool marking on a piece of metal, and as you can see, only a small portion is in focus. And now with the 3D microscope, the entire tool marking can be seen in focus. This tool marking can be easily quantified by employing the Edge 3D measurement system. Here is a 2D image of 2 strokes of a ballpoint pen on paper. Here is a full focus image of the 2 strokes of the pen. The question is, which stroke was created first, and which was created second? The 3D model shows that the pen markings create a groove in the paper. The 3D model indicates that the horizontal line was drawn after the vertical line. The color-coded depth image verifies that the horizontal line created the continuous groove, whereas the groove in the vertical line was interrupted by the horizontal line, meaning that that was the second line that was drawn. Here is an image of the microprinting on the end of a $100 bill. that says USA, USA, USA. Here is a closer 2D image of the microprinting, and you can see that only a portion of the image is in focus. The 3D image of the microprinting shows the three-dimensional nature of the quality of the printing. The Edge 3D research microscope shown on the left produced the images shown in this presentation.